Science fiction in the early 21st century was a bit of a muddle. There were many poorly advised films spouting utter nonsense. However, Christopher Nolan's Interstellar not only adheres to the science, but daringly tackles general relativity. Building on Nolan's work on exploring time, Relativity offers the ideal playground to link gravity, time, and Nolan's fertile creativity. Initially, Interstellar appears to have a number of ridiculous plot holes. However, the production employed Professor Kip Thorne. Like me, Thorne is a scientific advisor for the film industry. Unlike me, he is a proper scientist and a Nobel laureate for his work on gravity waves. He describes the good-natured battle with the director. He's like a Tex Avery cartoon character who manages to escape from seemingly impossible situations by sheer ingenuity. The film begins with a worldwide blight of many staple crops. Historically, reliance on a few genetically similar crops has led to disasters such as the Irish potato famine. A global infection of wheat and rice is entirely plausible, although many alternative and genetically diverse food sources exist. Professor Brand of NASA has a solution. Anti-gravity-propelled space stations, sealed against cross-contamination to grow the world's food. However, in order to get the system to work, he needs gravitational data from inside a black hole, an impossible conjecture. He lies about the project's true intentions and sends several astronauts through a conveniently situated wormhole to explore alternative worlds. But what exactly is anti-gravity? Electromagnetism is conveyed by photons, and strong nuclear force is carried by gluons. It is thought that gravity is projected by particles called gravitons. Unfortunately, a unified field theory that links all of these together is a mess. The discovery of gravity waves in 2015 suggests a solution, but no one is sure. One possible answer is a field of physics known as string theory, but unfortunately this is even more of a muddle. The predicted particles stubbornly refuse to be detected. Thorne is uncharacteristically non-committal in describing how gravity can be altered. Allowing for artistic license and new discoveries by the 2060s, then perhaps the anti-gravity drive is a method of manipulating gravity waves or gravitons by making a literal warp-drive engine. A device produces a gravitational field to pull the space station along, perpetually falling into its own gravity well. However, exactly why this would need data from inside a black hole is not clear. Perhaps the Brand Cooper team would be better employed searching for alternative experiments to verify the gravity equation. The spacecraft Endurance travels through a wormhole in the vicinity of Saturn. It emerges into a system of 3 planets orbiting a large black hole named Gargantua. The wormhole was created by a future civilization to enable 21st century scientists to discover the gravity data. The method of sending this data is rather odd, but the reason for this will become apparent from the underlying science. Wormholes are a theoretical means of linking 2 distant regions of space via a tunnel of curved spacetime. But what is curved spacetime? Our view of the structure of space and time comes from Albert Einstein's general theory of relativity. It is derived from Isaac Newton's inverse square law of gravity. This was one of the most fundamental discoveries in science and laid the basis of much of classical physics for the next few centuries. However, it bothered Einstein. It didn't make sense. What actually causes things to fall towards each other? Einstein's poetic answer was that our 3 dimensions of space and 1 of time were curved into a 5th dimension. We can't see it, but we can feel its effects. Surrealist artists have long imagined universes of nested dimensions, whereas science has a rather boring but visually useful model. Traditionally, 5-dimensional space is represented by a bendy rubber sheet. It doesn't look like this at all in reality, but it is mind-bendingly difficult to visualize in other ways. This convention is effective for large and heavy objects like stars and black holes, but doesn't really work for Professor Thorne's conjectured wormhole. This imagines a gradual slope down the hole rather than the abrupt cliff edge of a singularity. Interstellar's wormhole, he conjectures, is artificially built with gravitational field generators in higher dimensions. This is an idea from the derivative of string theory called M theory. The higher dimensions are called branes and reside in a multiverse called the bulk. This approach handily reduces the amount of time distortion. We see time distortion in the crew's journey to Miller's planet. This orbit's very close to Gargantua. Thorne was left with an almost impossible puzzle to create a planet where 1 hour on the planet becomes 7 years in normal space. Watching the film, I was extremely sceptical of this idea. I thought the gravitational force would rip the planet to shreds, or that such distortion would put the planet beyond the event horizon of Gargantua. Thorne, however, was particularly ingenious here. Normally a black hole occurs when a star loses the battle between heat expansion and gravitational collapse. The mass of the star falls inwards, creating an intense gravitational field and squashing the mass out of existence. A field so intense that not even light can escape, hence black hole. Thorne designed an isolated and anemic giant hole, one that had not been fed recently with star stuff. Stuck with Nolan's 1 hour 7 year ratio, Thorne came up with a clever idea. Spinning the black hole as fast as it can conceivably go allowed a region of distorted space. The effects of special relativity come into effect on Miller's planet and allow an extra boost of time distortion. This is difficult to visualize, but imagine water spiraling down a plug hole. The only difference is the water doesn't actually go down the hole, but appears to slow and stop at the edge. Pulled around by this vortex, the planet would be travelling close to the speed of light. Time is bendy at high speeds too. Viewed in 5 dimensions, a light beam has to climb up a steep gravity gradient. Viewed in normal 4 dimensions, the light beam would progress very, very slowly, which is of course impossible since the speed of light is always constant. Something must have happened to time to cause light to travel at the correct speed. Imagine a hotel sitting just above the event horizon, the point of no return. If the occupants of the hotel start pacing up and down, perhaps annoyed by the slow speed of room service, they would cover the distance in a certain amount of time. Seen in normal 4 dimensions, all the guests cover the same distance in the same time. But what if we could see into the 5th dimension? Due to the gravitational field, the rooms at the bottom appear to be incredibly squashed. Guests in the lower rooms are very compressed and cover a smaller distance in the same time. We know the actual distance and speed are the same, yet viewed this way they cover a much shorter path. The only explanation is that time must be running more slowly. Viewed from the outside in ordinary 4D, the guests in the lower floors make glacially slow progress. The situation becomes even stranger when Cooper descends beyond the event horizon. Nolan and Thorne constructed a tesseract. This is a 4-dimensional representation of a 5-dimensional space surrounding Cooper's farmhouse. Cooper transmits the required data to his 12-year-old daughter by manipulating gravity in higher dimensions. Thorne was quite adamant that Cooper should not be able to transmit information back in time via light waves. Nolan wanted a means of time travel to bring the plot full circle. A compromise solution was to use the higher dimensions in the bulk to convey subtle gravity waves back in time. Time flows only in one direction because of entropy, the tendency of things to fall apart towards maximum disorder. While evolution is an example of the reverse occurring, the general trend is still downwards. Thorne imagined a scenario where the bulk dimensions were less affected by entropy, allowing backwards time travel. The science is a little fuzzy as to how Cooper was able to leave the black hole and travel back to the solar system. Presumably he was able to use the tesseract machinery to travel in the bulk back through the event horizon and the crushing light-proof gravity of space-time. This is a rather more speculative aspect of the science and may be complete and utter nonsense. However, many technologies today were purely science fiction once. There is no precise law that says that travel through higher dimensions is impossible. At first glance, Interstellar seems to be a reasonable film with a clever plot twist and a fair degree of scientific accuracy. A more detailed look at the underlying science gives us the appreciation of how much work went into developing the film to be as accurate as possible. In many ways, Nolan's masterpiece is on a par with 2001: A Space Odyssey, and stands above many of the rather dismal and hopelessly inaccurate films of its era.